In this video, we are going to take a look at wrapping up our conversation about a random variable that is normally distributed. So to start this off real quick, I just want to remind us of where we've been. So in the last video, we looked at some applications, right? Some word problems where we're finding probabilities of a random variable. The video before that, we were just looking at the skill of finding area under the normal curve. So just to start off with that same idea. So back in that video, 2 videos ago, what we would have had is like a z-score of negative, let's say 0.73. And what we were being asked was to find the area under the curve. And we would interpret that as a probability. What we want to do in this video is we are going to be given the area under the curve, and we're going to be looking for that z-score that corresponds to that provided area. And typically the first thing that we want to do in a section like this or in this video is just develop that skill. All right, so let's take a look at a couple problems real quick where we're going to just talk about how to make this calculation. So again, let me draw a picture, and let's say I'm looking at a standard normal distribution, and let's say I know the area is 0.5832. Now to the left of the mean is 50%, right? So 0.5. So I know 0.5832 is going to be a little to the right of the mean because it's bigger than 0.5. Now, I don't know exactly where this z-score is. I'm just kind of guessing. So let's say we are told that's 0.5832. And what we want to do is look up that z-score that corresponds to that provided area. Right, if I'm doing this by hand, right, with tables, what I have to do is actually hunt through this table and find 0.5832. Now I can see right here, I don't know if you can see me highlighting with my mouse, 0.5832 is exactly in my table. So that's a z-score of 0.21 that would correspond to an area of 0.5832. So 0.021 would be my z-score. What did I say? 0.21. Man, my memory is just gone as an old man. So 0.21 was that value. So 0.21. Let me fix that sloppy writing. So if I'm doing this by hand, that's what I have to look up here. Now, just as a quick reminder, right, that if I'm finding the area to the right of a particular value, I would have to do 1 minus that, because my table only gives me area to the left. So let's suppose I want to find this z-score here. What is this z-score? And let's say that my area is, I'm going to just pick some crazy number. Let's say this is 0.6201, something like that, right? So I'm going to look in the table to find that value. Now what I really need to do in my table is 1 minus 0.6201, and that is 0.3799. Now I got to go to my table and hunt for 0.3799. Now again, this is going to be a negative z-score, right? 38% is less than 50. So 50 is below the mean. 38-ish% is going to be to the left. So I'm going to bring up my table. I need to go to the negative z-score, and I'm looking for 0.3799. So I had to hunt through this table to find that value. And I'm hoping I picked a value that isn't exactly in this table. So when I say that was 0.3799, where am I at? 0.37. So here's 0.3783, and here's 0.3821. So 0.3799 is going to be between these two values. So here's the issue with using the table is I have to kind of find where I'm between, and I'm typically going to pick the one that I'm closer to. So 0.3799 is going to be, let's see how far here. If I was at 0.38, this is 0.0021 units away. So 0.3799, I could subtract those numbers and see that I'm 0.0022 units away. I'm going to be closer to this one. I'm going to be 0.0016. So I'm 16 thousandths, 10 thousandths away. So I would pick this value 0.3783 because it's a little bit closer to 0.3799. So the z-score that corresponds to this is negative 0.3, and what is that next to the last column? 1. So negative 0.31 was that value. So negative 0.31. This is z equals negative 0.31. All right, it would be really convenient to use technology to find those values for us. So how would we use the different forms of technology to calculate those values? In my TI calculator, I'm going to do second vars to go to the distributions menu. You're going to see number 3 is called inverse norm. So I'm doing an inverse lookup. That's what most of the technology calls this. We're going backwards, right? So instead of having the z-score looking for the area, we're given the area, finding the z-score. This is reverse. Now if I bring back my Word doc, if I look at this first one we did, where the area was 0.5832, and that's to the left. I want 0.5832 to the left. So I'm going to type 0.5832. And because I'm doing z-scores, mean is 0, standard deviation's 1, and I'm choosing to the left. So I'm going to go down, paste, and there's that 0.21 value that we got on our Word doc. Right? Now again, the technology is going to be a little more accurate, but rounding to do decimal places, I'm getting the same thing. Now if I were to use a tool like Statcrunch, I'm going to click on Stat, go to Calculator, and I'm going to pull up my normal calculator. Now in this case, because I want area to the left, I'm going to be choosing the less than. What I'm going to actually do is delete this z-score. So I'm going to make that blank. Now again, because I'm doing z's, mean is 0, standard deviation's 1, and I'm going to type in my area here, which of course my old brain has already forgot. 0.5832 is my area. So I'm going to do 0.5832, and when I click compute, it's going to fill that z-score in for me of 0.21. In Excel, I'm going to click in a particular cell. I'm going to hit my function button. I'm going to start to type the word normal and hit enter. Now there's two norm inverses. This guy here, I specify the mean and standard deviation, which we haven't discussed yet. Norm.s.inverse is a mean of 0 and standard deviation of 1. So this is going to return z-scores. So I'm going to go ahead and double click or say OK. And it wants to find what is the probability. So it was 0.5832 to the left of that value. Now remember, Excel is always doing to the left. I can't tell Excel to go to the right or in between. So this is the cumulative to the left. So, our second problem that we did here, if I'm using Excel, right, in Excel I can't type in 0.6201, I have to type in 0.3799. So I would have to type in 0.3799, and it would give me that z-score of negative 0.31 that we found here. Now again, the kind of cool thing about Statcrunch or the TI is I can tell it to the right. So if I bring up Statcrunch, I can say go to the right. Again, I want to delete this z-score, and it was 0.5, we're doing this one, 0.6201. So I'm going to type in 0.6201. I'm telling it to the right, and when I click compute, right, there's that negative 0.31. And on my TI, 0.6201 was our value, I think. My old brain forgets. I'm going to do inverse norm, and I'm going to look that back up again. 0.6201 to the right, so 0.6201. Again, I'm doing z-scores, so I leave those alone. I'm going to the right. Arrow down, click paste, click enter, and there's that same z-score. Okay, so the really exciting stuff, right? Remember, the beauty of mathematics is in its application. So now that we've discussed the skill of given a probability or given an area, what z-score does that correspond to? Let's go ahead then and apply this to a word problem. So in this problem, I don't know why it's calling it number 12. In this problem it says assume that the salaries of elementary school teachers in the US are normally distributed with a mean of 28,000, standard deviation of 3,000. What is the cutoff salary for teachers in the bottom 10%? Again, I say this all the time. I'm a visual learner, so I'm going to note a roughly normal distribution. And these are thousands. I didn't give myself enough room to write here. So here's 28K. And if I want the bottom 10%, right, I'm wanting to know where that cutoff salary is, that I have 10% in that bottom. So I'm looking for that data value. Now the way we would do this by hand is we have to first find the z-score. We're going to first find the z-score, and then we're going to convert, that's a z, then we're going to convert that to, what is the actual data value within this application, that mean and that standard deviation. So I need to find the z-score that corresponds to 0.10. Now again, if I'm doing this by hand, I'm going to pull up my table. I want 0.10. Now again, I'm in the left tail, so I'm on the negative z's. And let's see, 0.10, where's 0.10? 0.10 is between these two numbers here, 0.0985, 0.1003. So 0.10 is closer to 0.1003 than it is to 0.0185. So I'm going to pick negative 1.28 is my column. Negative 1.28 is my z-score. So my z is negative 1.28. Now what this problem is asking for is what's the actual data value? So let's figure out, or let's discuss how we're going to do that. Now think of our z-score formula. Our z-score is we have our data value minus our mean divide by the standard deviation. What I'm looking for is this x value, my data value. I know my z, I know my mean, I know my standard deviation. So I'm going to plug the things in that I know, and I'm going to leave the x value alone because that's what I'm looking for. My mean's 28,000. The standard deviation is 3,000. So if we do a little bit of algebra here, I'm going to take the 3,000 and multiply it to the other side. And that equals x minus the 28,000 that I have. And then I'm going to take the 28,000 that's being subtracted, add it to the other side. And then I'm going to end up taking out my calculator here to find out what that actual x value is. So I paused real quick. I got $24,160. So with a mean of 28,000, standard deviation of 3,000, the bottom 10%, that cutoff salary is 24,160. So that would be my data value here. I'm going to do green just to highlight that. Right, that'd be 24,160 is the cutoff salary for the bottom 10%. So this is in essence the idea in this video. We're going to be given the area under the curve, and we're going to be looking for the z-score, which is the reverse of what we did in the prior two videos, and that's why the technology calls this an inverse norm. Now, if I'm going to use technology to do this problem for me, what does that look like? In my TI calculator, again, I'll do second vars. I'm going to call out the inverse norm. Now, since I don't really want z-scores, I'm going to change my mean and my standard deviation. So the area that I wanted was 0.10, and I wanted that to the left. So I'm going to come down here and change that in a moment. My mean was 28,000 for my teacher salaries, and my standard deviation was 3,000. And then I want to the left for the bottom 10%, down arrow, paste, hit enter, and there's the 24,155. Now, we got 24,160. We were using the table, and we had to, nudge ourselves to the closest z-score. The technology is going to give me a little bit more accuracy. Again, as I mentioned before, if you're doing an online homework system, it should accept either one of those answers, knowing that you may use the table and you may use technology. So let's talk about Statcrunch real quick. So I'm doing Statcrunch. Let me delete all of this stuff. Now, what we were just discussing a couple minutes ago is if I have Z's, I'm typing mean 0, standard deviation 1. In this case, I have my mean of 28,000, my standard deviation of 3,000. I'm leaving this value blank. Now I do want to the left, but I want 0.10 to the left, so my bottom 10%. When I click compute, there's my 24,155, or close to the 24,160. In Excel, clicking on an empty cell, clicking my function button. So I'm going to start to do normal. So we had the norm inverse, and let's see, this was the specified mean and standard deviation. The normal dot s dot inverse was a mean of 0, standard deviation of 1. So I'm going to choose the norm dot inverse so I can specify the mean and standard deviation. So remember, Excel is always to the left, and that's what we had in this case, 0.10 to the left. My mean was 28,000. My standard deviation was 3,000. And before I even hit enter, I can see it's giving me that number here and that number here. If I hit OK, hit enter, and there's that value. All right, so if I'm, in an online homework system, the problems may break this down into particular steps. They might ask you to actually find the z-score, so we would need to tell them the z-score first, and then they may ask for that data point. If they're just asking for the particular data point, we could be efficient and use the technology to help us, unless, I'm taking a test where I have to show all of my work to justify my answer. All right, I want you to pause the video. I want you to write this problem down for me, and I want you to attempt this. This is probably going to take you 5 to 10 minutes here. So pause the video, write this down, and when you're done, unpause, and we'll look at this together. All right, welcome back. How did you do? All right, sounds like you guys did really well. All right, let's take a look at this real quick. So I went ahead and sketched the graph, so you didn't have to watch me do that. So normally distributed data, I'm told here. And I have the mean of 81.4, a standard deviation of 9.3 for scores on this algebra test. So this says if the top 5% and bottom 5% are excluded as outliers, what is the range of scores that will be kept? So I have bottom 5% to the left, top 5% to the right. And what I'm looking for is, what are these range of scores? So what score is this? What score is this? And I'm going to be keeping the scores in between here. So by hand, we need to find the z first and then find the x value next. So if I'm doing by hand, I'm bringing up my table first, and I want 0.05 in the left tail. So I'm going to go ahead and find the negative z-score with 0.05. So let's see, where is 0.05? Okay, it's right between these two guys right here. And notice it is smack in the middle of these two. So 0.0495, 0.0505, 0.05 lies right in between. So the standard rule is I'm going to go smack in the middle. So for example, if I look at 0.0595, this is negative 1.65. And then where was I at? 0.0505 is negative 1.64. So what we would do is go smack in the middle. Negative 1.645 is the z-score that we're going to use there. So negative 1.645. Now because of symmetry on this graph, the top 5% is going to be positive 1.645. So no need for me to really look that up to double check that. So what will be the x value that corresponds to that? Now we could use a shortcut. Right? Remember what we did last time is we had z equals x minus the mean over the standard deviation, and we solved for the x. So I multiplied this sigma over, and I added the mean. So z times sigma plus the mean. A lot of books will give this to you as like the formula for finding an x data value given a particular probability. So we know our z. Our z was, what did I say? Negative 1.645. So we got negative 1.645. Our sigma was 9.3. 9.3. And then we're going to add to that our mean, which was 81.4. So in my calculator, I'm getting 66.2875. So I'm going to go ahead and round this. Since all of my data, my scores is to one decimal place, I'm going to go ahead and round this to 66 point, that would be 66.3% as my test score. All right, so now I'm going to go ahead then pause again. I'm going to plug in positive 1.645 here. Crunching that in my calculator, I get a score of 96.17. So I have 96.7, sorry. So any score between 66.3 and 96.7 will be kept. Any score to the left of 66.3 will be tossed out as an outlier. Any score above 96.7 will be tossed out, and the top 5% as an outlier. So we will keep scores between, I'm going to get lazy and say between 66.3 and 96.7. Now, if I'm using technology to calculate this for me, I'm going to bring up my TI. And again, if I do second vars and go to the distribution, I'm going to do inverse norm. And I'm going to, oh, you know what? Let me check this out. I can do center here. Let's think of our graph for a second. If I have 5% in the right and 5% in the left tail, that's 10% collectively. So I really have 90% in the center. So I'm going to use my TI to do that. I'm going to say 0.9. And my mean, oh gosh, mean was 81.4, standard deviation 9.3. So I type those in, and then I'm going to choose center and paste, and there's our 66 and 96 that we got, 66.3, 96.7. Right? And I think probably what's happening here is technology is a little bit more accurate. Maybe why I'm a little bit off in that case. So if I'm using Statcrunch, I'm doing the same type of thing. Remember, Statcrunch has this between feature. So my mean was 81.4. My standard deviation was 9.3. And what I want in this case, let me delete. I want the 90% between. So I'm going to compute, and there's my two values. And then lastly with Excel, Excel's a little more of a pain, right? So I'm going to choose normal inverse, and Excel always wants areas to the left. So I'm going to have to do the 0.05 in the left tail, the mean of 81.4, the standard deviation of 9.3, and it's going to give me that cutoff value we can see here, and then we could repeat the same. So with Excel, if I bring back my Word doc, if I have 0.05 in the right tail, I have 95% all the way below. So in Excel, I would need to do 95% all the way below, and we can see there's that upper score. So this wraps up this last section where we're discussing normal distributions, normal random variables. If you have any questions, feel free to comment on my video and ask some questions. Otherwise, I look forward to seeing you in the next video.